Okay, right, this is a video on calculating the gradient. We're going to look at two ways of calculating the gradient. First we're going to look at calculating the gradient from two coordinates, and then we're going to look at, if we just look on the next page, we're going to look at how you find the gradient from graphs. Okay, now I'm doing this one, although this one is probably slightly harder, you might prefer this method and then want to use this method on doing it from graphs. Okay, so that's why I'm doing it in that order. Okay, right, we've already talked about in the previous video that the gradient is the steepness. Okay, that is what gradient means. And if we think about the general equation of a straight line, the general equation of a straight line is y equals mx plus c. We talked about that on the previous video, where m is the gradient. So the higher the gradient, the steeper the line. So the higher the number in front of x, the steeper the line is. Okay. Now, how do we calculate this steepness? Well, we calculate it by doing the distance up divided by the distance across. Okay. Now, if we want to do that sort of algebraically, or you might prefer to remember more practically, that is your y2 minus y1 divided by x2 minus x1. Now, what that means is your second y coordinate, take away your first y coordinate, divided by your second x coordinate, take away your first x coordinate. Okay. Now, when I'm saying first and second, I don't mean it has to be in that order. I just mean if you've taken the y coordinate from one of your coordinates, that x coordinate has to come first as well. You can't interchange the coordinates. Okay. Right, so we're going to look at this and I'm going to try and use this, but I'm also going to interchange using distance up divided by distance across and y2 minus y1 over x2 minus x1. Okay, so let me write that somewhere so that we've just got it on the sheet. So we've got the gradient is the y2 minus the y1 over the x2 minus x1, which is the distance up divided by distance across. It doesn't matter which one you use as long as you're happy with how to use it. Okay, right, so when we are doing this, let's first of all label our coordinates. So let's call this coordinate, these are obviously our x coordinates. So let's call this one x1 and that one x2, this one y1, this one y2. Doesn't matter which way around you call them, as long as if this is x1, this has to be y1. If this is x1, this has to be y1. Okay? So, to calculate the gradient, we're doing the distance up. The distance up is the distance in our y coordinate. So if you wanted to, if you didn't want to use this, you could say that is your up coordinate and that is your up coordinate. Okay, so we do the distance up is 15 take away 10, which is y2 minus y1. We really ought to write how we're doing it. Okay, so if you're using the distance up divided by distance across, you write that down. If you're using y2 minus y1 over x2 minus x1, you write that down. Okay, so it's going to be 15 take away 10 divided by x2 minus x1, which is the distance across. Distance across is our x coordinates, 6 take away 5. 15 take away 10 is 5, 6 take away 5 is 1, 5 divided by 1, our gradient is 5. Okay, so the gradient of the line that crosses through these points is 5. Okay, question 2. So again, we're trying to calculate the gradient, so we're going to do either the distance up divided by the distance across, or y2 minus y1 over x2 minus x1. Okay, so let's say this is x1, this is y1, this is x2, this is y2. Okay, so we're going to do y2, which is 10, minus y1, which is 6, over x2, which is 8, minus x1, which is 7. 10 take away 6 is 4, 8 take away 7 is 1, 4 divided by 1 is 4. Okay, right, let's go at number 3. Calculating the gradient. So the gradient is y2 minus y1 over x2 minus x1. Here's x1. I would label your coordinates every single time. Doesn't matter which way. Oh, that's x2, sorry. Doesn't matter which way around you do it as long as you get your x's and y's the right way around. Okay, so we've got 18 take away 4, y2 minus y1 over minus 3 minus 1. Be careful with your signs here. So 18 take away 4 is 14. Minus 3 minus 1 is minus 3 plus 1, which is minus 2. 14 divided by minus 2 is minus 7. So that has a gradient of minus 7. Okay, number 4. x1, y1, x2, y2. Our gradient, again, I'm using y2 minus y1 over x2 minus x1. So I've got to do 5 take away 13 over 10 take away 6. So 5 take away 13 is going to be negative 8. 10 take away 6 is going to be 4. Minus 8 divided by 4 is minus 2. It has a gradient of minus 2. Okay, that is how you find the gradient when you've been given a pair of coordinates. We're now going to go on to look at how you find the gradient when you have been given a graph. Okay, now I'm hoping you can see this, okay? We'll roll with it. Right, so we're trying to find the gradient of each of these lines. I'm going to split them all up, okay? Now, I would always write at the top how to calculate my gradient. So it's either going to be the distance up divided by the distance across, or it's going to be y2 minus y1 over x2 minus x1, okay? Now, there are two ways to do it. Let's use method 1 to start with. Method 1 is to use the distance up divided by distance across. So you pick a pair of coordinates, and I would always pick them so that they're integer values. So let's say we can pick, let's do it in purple so we can see. Let's pick this one here and this one here, because they're both on the actual coordinates, okay? All we're going to do is do the distance up, which is that distance there, divided by the distance across. So quite visually, it's easier to see. So distance across obviously is 2. Distance up is 1, 2, 3. So our gradient is 3 over 2, which you can leave as 3 over 2, or you can write as 1.5. Okay. Now visually, that obviously seems quite easy. Okay, but the second method would be you pick your two coordinates again. Okay, so and then I'm going to write down what those coordinates are. So that is 0 along the corridor, up the stairs, or down the stairs in this case. And this one is minus 2, minus 5. Okay, you can then use this formula for the gradient, y2 minus y1 over x2 minus x1. And the reason you might prefer this is because you might get into the habit of using this formula and then want to use this formula forevermore. Okay, so in these coordinates, that can be x1, that can be y1, that can be x2, that can be y2. So we're going to do minus 5 minus minus 2 divided by minus 2 minus 0. Minus 5 minus minus 2 means minus 5 plus 2, so that makes minus 3. Minus 2 take away 0 makes minus 2. And minus divided by minus is a plus, so that is just 3 over 2, which is also 1.5. Okay, either method is totally fine. Whatever you would like to do is totally fine. Okay, right, so let's look at this second one. Same thing again, I'm going to do it both ways, make sure you're happy. So this is the distance up divided by distance across. I'm going to pick a couple of coordinates that I can see are on integers, so I'm going to go for that one and that one. I could do that one and this top one, okay? It doesn't matter how far away they are, as long as you can see it, that is fine. So the distance up is 2, distance across is 2, so my gradient is 2 divided by 2, which is 1. That's method 1. Or pick your coordinates. So my coordinates here are going to be 0, 1 along the corridor up the stairs, and 2, 3. And then my gradient is y2 minus y1 over x2 minus x1. So it's going to be, here's x1, here's y1, here's x2, y2. Don't forget to do this every time. Don't be lazy, label your coordinates. Okay, so we've got 3 take away 1 divided by 2 take away 0. 3 take away 1 is 2. 2 take away 0 is 2. 2 divided by 2 is 1. Gradient is 1. Okay, and the last one, question C. Now I'm going to take a bigger jump this time just to show you that it still works. So let's take this coordinate and this coordinate, okay? Right, so here's our triangle. Our distance up, let's write down what we're doing. So our gradient is the distance up divided by the distance across. Okay, so our distance up is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And our distance across is 1, 2, 3, 4, 5. So our distance up is 10, our distance across is 5, and so our gradient is 2. Or we can take two coordinates. Should we take the same two coordinates, or should we do different ones? Let's do different ones, mix it up. So we can do that one and that one. How about that? So we've got this coordinate here is 0, minus 3. And this coordinate here is 2, along the corridor up the stairs 1. We are now going to use, hope you can still see that. We are now going to use y2 minus y1 over x2 minus x1. Here's x1, here's y1, here's x2, here's y2. So we've got 1 minus minus 3 over 2 minus 0. 1 minus minus 3 is 1 plus 3, which is 4. 2 minus 0 is 2. 4 divided by 2 is 2. So here I use different coordinates. I use these two ones far apart to do this bit. I use these two here to do this bit. Gives me the same answer. Obviously, that just proves that maths works. Okay? That is how you calculate the gradient from a pair of coordinates and straight lines given.